Mount the cross arm, the entire assembly will not come down upon you.
Remove the cross arm from the B box and place it in the cutout located in the upper portion of the reflector support assembly. Orient the cross arm so the welded cross supports are on top. Push the cam lever pin on the underside of the reflector support assembly through the cross arm. Rotate the cam lock 90 degrees and lock the cam lever. Remove the 2 feed supports from the C box and match the color band at the end of each feed support with the colored boxes around the threaded holes on either side of the feed boom. Attach the feed supports to the feed boom, but do not tighten the thumb screws completely. Attach the other end of the feed supports to the cross arm. Now hand tighten the 4 thumb screws. Loosen the top elevation adjustment wing nut on the AZEL positioner and tilt the reflector support assembly back as far as it will go. Temporarily secure the reflector support assembly in position by tightening the bottom elevation adjustment wing nut against the stop. Remove the reflector panels from the A box and assemble the 2 reflector panel halves by pushing each of the 3 cam lock pins from the bottom half through the corresponding hole in the upper half. Do not lock the cam levers until all 3 pins are through the holes. Rotate each cam lock pin 90 degrees and lock the cam lever. Loosen the cam lever on the lower portion of the reflector support assembly near the feed boom hinge. Orient the reflector panel so that the concave side is facing up and the 2 mounting brackets are at the bottom. Lay the assembled reflector panel on the reflector support assembly and crossarm. Place the mounting bracket into the cam lock. The mounting bracket should be inside the washers on the cam pin lock. Do not tighten the cam lever yet. Align all 4 reflector fastening bolts, 2 on the reflector support assembly and 2 on the crossarm, with the threaded holes in the back of the reflector panels. Thread each bolt into the reflector holes just enough to capture a few threads. Do not tighten the 4 bolts yet. Verify the reflector mounting bracket seating on the cam pin, but do not lock it. Tighten the 4 reflector fastening bolts. Tighten each bolt a quarter turn at a time, moving from one bolt to the next until each bolt is finger tight. Over-tightening will strip the threads and crack the reflector. Lock the cam lever at the bottom of the reflector. Loosen the elevation adjustment wing nuts and tilt the reflector support assembly forward so that the end of the feed boom is about level. Remove the feed horn from the A box and mount it on the end of the reflector support assembly with the funnel-shaped portion with the plastic cover facing the dish. Tighten the screw that attaches the feed horn to the feed boom, finger tight. This completes the assembly of the 300 series ViaSat. Now move to the next chapter, aiming and commissioning the ViaSat. In this section, you'll be aiming and commissioning the ViaSat. This is the most complex series of steps and processes and the most critical for successful deployment of the ViaSat. For this segment, we will study 4 topics. We will demonstrate the tools that are used to aim the ViaSat. We will show how to connect the e-box, server, and ViaSat cables. We will power up the systems, and we'll aim and commission the ViaSat. But first, let's look at some of the tools we need to aim the dish.
Now that you've assembled the satellite, we're at the point of roughing it in using 3 key tools. Our site selection worksheet, our walkie-talkie, which we'll use to communicate with our associate inside, and our clinometer, which we'll use to sight in the azimuth, elevation, and polarization offset. One of the most important things to remember is the elevation offset. You'll remember from your eyesight training that the flyaway kits require a negative 17.9 elevation offset. Another item to remember is each foot of the ViaSat requires 100 pounds of ballast. We highly recommend using an enclosed sandbag for this. Please do not put the sandbags on the leg of the ViaSat, only on the feet of the ViaSat. Using the clinometer is very much like using a compass. On the front of it we have the azimuth, which is your north, south, east, west, in degrees. You can either use it like a normal compass, pointing down, sighting your numbers, or looking through the small window, which will also give you your degrees. It's very important to hold it level. The other side is for your elevation. Looking through it on the left-hand side, you'll start sighting in your elevation. For aiming the satellite, we're working with two different planes. We're working with the azimuth and the elevation. For azimuth, it's best to find a fixed object in the general vicinity to start roughing in the satellite. We get those figures off of SatMaster, which we previously written down. The next step will be to rough in the elevation to the points off of SatMaster. For that, we look for a clear image in the sky to make sure there are no obstructions. Now that we've roughed in the dish a little bit, we're going to start working with the two different tools we'll use, both the elevation adjuster and the azimuth adjuster. The elevation adjuster lets you move the dish up and down, and the azimuth adjuster lets you move the dish side to side and left to right. Again, with everything on this dish, when you're doing small adjustments, make sure not to pinch your fingers, as the dish can swing with wind. Once you've roughed in the dish, all the other adjustments are going to be in very, very small turns, no more than a 1/4 inch at a time, as a small turn can make a large adjustments on the satellite dish itself.
Along with azimuth and elevation, you'll also need to adjust the polarization offset. This is a critical step. To set polarization, place the clinometer oriented vertically with the straight edge against the side of the L&B. There's a set screw on the side of the L&B that will allow you to move the entire fixture. So if you sight through the eyepiece on the left-hand side of the scale, you'll be able to set the polarization offset to the exact setting. To summarize, there are 3 variables that you need to adjust. The azimuth to set the dish to the compass bearing, the elevation to find the satellite in the sky, and finally the polarization. This sets the VSAT for the red cross port on the satellite. Making connections. Now we will connect the E-box to the VSAT and we'll connect all the server cables. The E-box sits inside near your operations center. Leave the cable spool indoors and run the cable to the VSAT. Connect the F connector to the L&B. This is the smaller box and it's the receiver. Connect the N connector to the buck. This is the transmitter. Now go indoors and unwrap the cable from the outer storage hole on the reel. Connect the 2 leads from the cable reel to the E-box, now positioned on top of the D-box. Make sure you attach them properly. One is marked Transmit, TX, and the other RX, Receiver. And the plugs are of different sizes as well. Remove the power cable from the E-box and plug the unit into a wall outlet. With your laptop server on top of the E-box, take the short Cat5 cable from the Dell laptop server to port 2 of the Cisco switch. On the 400 series, verify that port 1 on the Cisco switch goes to the LAN A port. On the 300 series, verify the red iDirect router Cat5 cable connects to port 1 of the Cisco switch. Also, check the field instructions to make sure the laptop server for the 300 series is connected properly. The 400 and the 300 series have slightly different configurations. Here are a couple of the key steps in this section. We'll plug in the AC power, and we'll secure the laptop server to a case, power up the UPS, and turn on the iDirect. Plug in the AC power for the laptop server into the UPS rack, being mindful of the other plugs already in the rack. And then connect to the power port on the laptop server. Secure the laptop with the wire cable in lock. Run the wire cable through a handle on the E-box and attach to the computer. You may have to check with your supervisor for the lock combination. Power up the UPS by pushing the larger button. When the unit is plugged into an outlet, the bottom row of lights will illuminate, indicating that batteries are being charged. After the power switch is activated, the system will go through a series of diagnostic tests. The top row of lights shows the load on the system. The small light to the right of the main power switch indicates the UPS is receiving alternating current power. If you lose power or if the default light illuminates, contact your supervisor. Now turn on the iDirect router. You are now ready to commission the ViaSat. This is typically done with two people, one who is outside and another who is inside with the ViaSat server. In this last section, part 4, we'll turn on the power to the laptop. We'll pre-point to the receive site that's selected by the NSC. We'll aim the ViaSat, and we'll do our final tuning. Open the ViaSat server laptop and turn it on. After it boots, you will see this screen. Press the Alt-Delete keys simultaneously, and then enter ViaSat for username and password. Prepare the iDirect satellite router to look for the correct land Earth station. There are several icons on the desktop labeled Prepoint and a city. You'll need to call the Network Support Center to get the proper icon. Press any key when prompted, and the lights on the iDirect router will go off. Start the iDirect application by double-clicking the iSight icon. iSight opens displaying two panes underneath the toolbar. The left pane contains the tree view, which shows the iDirect device, labeled as TDMA remote number 3100, and the device's IP address, which appears on the label on the front of the e-box. If the iDirect device does not appear, then you have a power or a network connectivity problem. The most common reasons are laptop network cable is not connected at the laptop or switch, the iDirect satellite router is off or not fully booted up, or the Cisco switch in the e-box is disconnected. Double-click on the TDMA Remote 3100 line to log in on the iDirect satellite router. In the Login dialog box, make sure that you log in as admin. Enter the current password, and if you don't know the password, call the NSC. The Configuration at TDMA Remote 3100 window will open in the right pane. This window shows the current configuration of the iDirect device. Click on the antenna pointing icon. It is on the toolbar, the line of icons across the top of the pane, and it looks like a satellite dish. When the mouse is hovered over the icon, a text box Antenna Pointing appears. The Antenna Pointing window will open up. Click on the Antenna Pointing tab. The Antenna Pointing tab monitors the receive signal strength for fine-tuning. The signal strength displays on the graph and in the current signal strength field. In addition, a tone sounds that changes pitch relative to the signal strength.
I'm going higher, 3.9, 4.1,
and provides a numeric value on the signal strength window.
13.4.
To begin the process of commissioning the satellite, have the person outside set the satellite dish 20 degrees off from the anticipated location for the satellite. This will give a zero reference for the antenna pointing. Begin monitoring the signal by clicking on the Start button. Before the monitoring begins, a warning dialog box appears. Disregard the instructions. Click OK to start monitoring. It will take about 10 to 12 seconds for the graph and the value to appear. With one person inside watching for changes in signal strength, have another person outside at the antenna making small adjustments to the azimuth and elevation by turning the adjustment wing nuts in quarter of a turn increments. Make adjustments in one axis, either azimuth or elevation at a time.
5, 14, 15, we're in the green.
Move the dish in both directions, left or right, until the highest field strength is reached for that axis. Then make adjustments to the other axis, moving it up and down until it reaches the highest signal strength. Repeat these adjustments in quarter turn increments until reaching the highest signal voltage with a green scale. Ideally, the voltage should be between 16 and 18 volts. If you spend more than a half hour without getting a yellow or green signal,